Hello ladies and gentlemen, this is Mrs. Eisenman. I'm going to take you through the Unit 4 study guide, so let's get started. Okay, let's get started. Just a reminder, Mrs. Hennessy and I would both encourage you to first try these problems on your own and then use this as a way to check, or if you get stuck, a way just to kind of give you tips to study for the test coming up. All right, so the first one is solving a literal equation, and you're asked to solve specifically for the variable n. So I'm going to start off by taking my equation, y equals 5a n squared. And if I want to solve for n, I first want to isolate the n squared. So I want to ask myself, what operation is going on between the numbers that are attached to the n squared on the right-hand side of the equation? And I would say that if I look at what's happening here, 5a and n squared, the operation is definitely multiplication. So to undo multiplication, the inverse operation would be to divide by 5 and a to both sides, making it y divided by 5a is equal to n squared. Now it's the squared that I want to undo, and so I just have an n. So how do I undo squared? Well, the inverse operation for squaring is taking the square root. And remember, the reason why that works is because we just said squaring and square rooting are inverse operations, so they cancel each other out, leaving us with n is equal to the square root of y divided by 5a. Okay, number 2 is on recursive sequences. Number 2 says a sequence is defined recursively by, and remember, recursive sequences have to give us two things. They have to give us your first term, f of 1 equals -8, and they have to give us the rule to find the next term. And that's what this says. F of n is equal to f of n minus 1 plus 3. This is like saying to find the next term, I have to take the previous term and add 3. So this rule is basically just telling us take the answer from the term before and add 3 to get the next term. We are asked to find specifically f of 4. So with recursive sequences, we can't jump right to the fourth. We have to go step by step like a ladder. So we start by writing down what we know. The first term is f of 1 is -8. Now, to find the second term, that's equal to the term before it, which is the first term, which is -8 plus 3. That's what this rule is saying. And so we get -5. To find the third term, I just take the answer from the term before it, which was -5, and I add 3. Okay, this rule keeps telling me to find the next term, I take the previous answer and add 3. Okay, so that's going to be -5 plus 3, which is -2. To find the fourth term, which is of course the one I want, I take the answer from the term before, which is -2, and add 3. And so I get 1. The fourth term for this recursive sequence is 1. You should notice a very repetitive process of what just happened. So if you look here, we started with -8, that got plugged in here, and we got out an answer of -5. Then that got plugged in here, we got out an answer of -2. Then that got plugged in here, and we got our final answer of 1. Okay, so that is a process that keeps repeating. So once you understand this rule right here, you are golden. So understanding that the next term is equal to the previous plus 3 is the key to being able to answer that question. Okay, the third topic here is on arithmetic sequences, and they give us the formula for arithmetic sequences that we definitely are going to use throughout this problem. So the question says, Linus is starting a new workout routine. The first day he will exercise for 15 minutes. He will increase his exercise time by 4 minutes each day. Write an equation for t of d, the time in minutes spent exercising on day d. Find t of 6, the minutes he will spend exercising on the 6th day. Okay, first of all, what part of this question indicates to me that this is an arithmetic sequence? Well, First of all, arithmetic means that it goes up by a constant amount or down by a constant amount. So the fact that we are going up specifically by 4 minutes each day tells me it's arithmetic. Now, why am I using the arithmetic sequence formula though, and not the equation for just a linear function y equals mx plus b? It all depends on how the problem is presented to us as to which one we are going to use. In this problem, we're specifically told what the first day of exercising is, how many minutes he spent exercising on his first day. That is telling us the first term. And when we're given the first term, that is what gives us the indication that we should be using an arithmetic sequence. And so here, as you read this problem, it says the first day he will exercise 15 minutes. That's our first term. Okay, now this problem is a little confusing because we're talking about an arithmetic sequence, which means we're going to use this formula up here. But at the same time, they use T of D for D days, blah, blah, blah. So what we're going to do is start by using this formula, and then we'll work into the T of D at the end. Okay, so I'm just going to start right away with this formula. If I am using an arithmetic sequence formula, I need to fill in two pieces, A sub 1 and D. We leave N as N. Okay, A sub 1 is our first term, which we just talked about. That was given to us as 15 minutes. That is the number of minutes he exercised on the first day. D is short for common difference. It's what our constant rate of change is, what we're either increasing or decreasing by each day. Because we are increasing by 4 minutes each day, our common difference is 4. So now I'm going to take that arithmetic sequence formula that, remember, is given to you on an exam, and I'm going to plug in the A sub 1 and the D. I'm going to leave my N as N. Okay, here's when I'm going to go ahead and make the transition to T of D. So now this is my arithmetic sequence, and they use, in general, arithmetic sequence always uses A sub N. Well, in this problem, they want us to write as a function for time in terms of the number of days. So I just replace A sub N with T of D, meaning my N gets replaced with D for number of days. Okay, so this is the formula using function notation for T of D, where T stands for the number of minutes and D stands for the day. Okay, so now if I want to solve T of 6, which is the amount of minutes, the amount of time he spent exercising on day 6, I would simply replace my D with a 6. So 15 plus 6 minus 1 times 4. I can type that in my calculator, and I will end up with 35. So 35 minutes is my answer. Okay, the next problem that we have to look at is talking about inequalities, the next two that we're looking at here. And so the first one, review from earlier in the year, what is the smallest integer that satisfies this inequality? So I'm going to rewrite it. Negative 2x plus 18 is less than 8x minus 12. Okay, to solve this inequality, I want to get my x's to one side and my numbers to the other. Remember, with inequalities, it's helpful to try to keep your x's positive, so therefore we don't have to worry about switching the inequality sign when we divide by a negative. So I'm going to add my 2x over. Okay, that's going to eliminate it from the left-hand side. So 18 is less than 10x minus 12. Of course, need to move my 12 over now. So 30 is less than 10x. Divide by 10. So 3 is less than x. Now, when I read inequalities, it's usually helpful to rewrite it so that I can see it with the x on the left-hand side. So I'm going to write it as x is, now notice here, when I look at my inequality sign, it is open to the x. It's wider to the x. So when I write it, I'm going to make it open to the x, wider to the x. It's pointing at the 3. So I'm going to make it pointing at my 3. So x is greater than 3. That's what this says. X is greater than 3. Now, at that point, a lot of students think they're done. But notice that the question asks what is the smallest integer that satisfies the inequality. So, what is the smallest integer that is greater than 3? So think about our numbers that are greater than 3. Obviously, that starts with 4 and goes up from there. So 4 is the smallest integer bigger than 3. Okay, number 5. In order to go on the senior math trip, Marcy needs at least $470. She has $265. She is tutoring freshmen for $10 per hour to raise the rest of the money. Write an inequality to represent the number of hours, H, she must tutor. Okay, lots of information here. But one thing I really want to point out, and I've said this many times to my students, look for that key word. They're telling you to write an inequality. Don't miss that. If they're telling you to write an inequality, let's make sure we have either less than, greater than, less than or equal to, or greater than or equal to in our problem. So let's go back and look in our problem and see if we can find the hint as to which of those inequality symbols we are going to be using. Hopefully you zeroed in on the words at least 470. At least 470 means I'm talking about greater than or equal to $470. Now I have to build the left-hand side of my equation, or inequality, using the other pieces of information. So she's starting with $265. She already has that in the bank. And then she's going to tutor freshmen for $10 per hour. Remember, we've talked many times about that per hour. Per hour is giving you an indication that that's where your variable is going to be stuck to that number, so 10H. And of course, if she is tutoring for $10 per hour, that's going to add on to the $265 she already has. So this is your inequality that you have to write for full credit. 265 plus 10H is greater than or equal to 470. Okay, number 6 and 7 both deal with the topic of functions. Number 6 is specifically looking for us to evaluate and compare function values. So given that f of x is equal to negative 3x plus 2 and g of x is equal to 4 minus x, at which value of x is f of x greater than g of x? This is super important. They're asking us to compare the outputs given different inputs. So these are different possible values for x. Okay, all of your choices are different possible values of x. We are going to plug them into our two different functions, f of x and g of x, and see which one gives us back outputs where f of x is bigger than g of x, where the f output is bigger than the g output. So we're going to start with choice A, okay? And we have to test it in. So remember, they are giving you different x values. So I'm going to test what is f of 4. Well, that means I'm taking this equation, this function, and I'm putting in 4 for x. So negative 3 times 4 plus 2, f of 4 would equal negative 10. Okay, now I'm going to do, okay, so now we need to go ahead and evaluate g of 4. And so we put in g of 4, we put 4 in for x, so it'd be 4 minus 4. G of 4 is equal to 0. So this is where the comparison comes in. We have to now ask ourselves, okay, is the f output of negative 10, is that greater than the g output of 0? And clearly we would say no. Okay, so now we're going to go ahead and try B, where x would be 3. So I'm going to do f of 3, which is going to be negative 3 times 3 plus 2. So f of 3 would equal negative 7. And then I'm going to evaluate g of 3, which would be 4 minus 3. So g of 3 would equal 1. When I compare those, I get negative 7. That's our f output. Is that bigger than 1? And again, the answer is no. Okay, and so now I'm ready to look at C. C you should have changed to x equals negative 2. Okay, and so f of negative 2 is equal to negative 3 times negative 2 plus 2, which would be 8. G of negative 2 is equal to 4 minus negative 2. G of negative 2 here would be 6. course, I'm using my calculator to do these calculations so that I'm sure I'm getting them right. Now I'm comparing my F output. Is it bigger than my G output? And this time I would say yes. So in fact, C is the right answer. X is equal to -2. Okay, number 7 is asking us to determine if the following is a function. Explain why or why not. So we look at these set of points, and we have the point -2, 0, 2, 1, 2, -3, and 7, 5. Hopefully you're saying to yourself that this is, in fact, not a function. Okay, and why would I say that? What is my explanation? Well, you should notice that we are repeating an x value of 2 with a different y values. So our explanation could be that x equals 2 repeats with different outputs. All right, number 8, writing equations. Sally has 18 coins, all dimes and quarters. The total value is $3.85. If D represents the number of dimes, could the following represent this situation? Explain your answer. So hopefully Mrs. Hennessy and myself told you that this is the equation that you should have written down instead of the one that's there. All we did was change the n's to d's. Okay? So if I look at this problem, they do tell me that D is the number of dimes. I have 2 unknown quantities though. I also have Q, the number of quarters. So I've identified my variables. Okay, if I read through this problem, I notice that I have 2 different totals. I have a total number of coins and I have a total dollar amount. Okay, so my totals, I'm just going to kind of make note of that, are 18 coins and $3.85. Oops. Okay, so now I'm ready to write my equations. And my 2 totals are going to give us the endings of my 2 different equations. So I have an equals 18 and an equals $3.85. The 18, remember, has a unit of measure of coins. So I should be adding the 2 different kinds of coins together to get the total number of coins. So D plus Q equals 18. My other total is $3.85. So dollars, I have to bring money into the left-hand side. This is where we remind ourselves that dimes are worth 10 cents and quarters are worth 25 cents. And so we have that equation. Okay, now when I compare my equations with what I'm trying to build up to, which is what they gave me over here, okay, first of all, I notice that I don't have any decimals. And so we've talked about that you can take an equation with decimals, and as long as you consistently move the decimals in every single term, you can go ahead and do that. So if I rewrote this as 10D plus 25Q is equal to 385, that's legal mathematically because I moved the decimal in each one of these 2 places. So as long as you do it consistently to every term in the equation, then you can go ahead and do that. Now that's looking much more like what we have there. Okay? The only difference is in the equation that I'm looking at that I'm trying to prove is or is not the right one, I have this 18 minus D in place of where I have a Q. So what I need to say is, what can I do to replace my Q? Well, that's where I'm going to take my first equation and solve for Q. So I'm going to subtract D from both sides, and I get Q is equal to 18 minus D. Now, if I took that 18 minus D and replaced it in the Q, would I in fact get the equation that they give me? Absolutely. But notice that they use that word explain. They say explain your answer. Okay, so you might want to say the words, I solved for Q and then substituted 18 minus D in for Q. Okay, that's explaining how this equation here matches what you're doing. All right, so you have your mathematical explanation, but I also wrote down just a verbal explanation. Okay, number 9, systems of equations. Last week, Starbucks received $2,048 for selling 700 pumpkin spice lattes. A small latte sells at $2 and a large latte sells for $3.50. How many large lattes did Starbucks sell? Okay, so they are asking specifically for the number of large lattes, but of course there are two different unknowns here. We don't know how many small lattes or how many large lattes were sold. Okay, so those are my variables that I defined. X is the number of small lattes and Y is the number of large. All right, just like last question, we have two different totals. Okay, so if I kind of organize those, my totals are 700 lattes sold and $2,048. So those are my two different totals that I have to work with it. Okay, so first of all, 700 total lattes. Well, what different types of lattes did they sell? Small and large, and they add together to be 700. Okay, next, they tell us that a small sells for $2 and a large sells for $3.50. So I'm going to bring in money, with money. So 2x, $2 for every small latte, plus $3.50 for every large latte is equal to our money total, $2,048. Money goes with money. All right, now I need to solve this. Now I want to be specific and careful about solving this because it says how many large lattes. Well, if I want to know how many large lattes, that really means I'm trying to solve for my y variable. Okay, so that means as I use the elimination process, I'm going to try to eliminate the x variable. In order to eliminate a variable, we need to multiply by a number so that we have the same number but opposite signs. So if I look here, what number would I have to multiply so that I can eliminate my 2x right here? Well, that would make sense that I multiply the top by -2. Okay, that's going to make it the same number, 2, but opposite. So I'm just going to carry that across. I would have -2x minus 2y is equal to -1,400. Notice I'm multiplying every term by -2. Okay, so then I just copy over the bottom equation. The 2x plus 350y is equal to 2,048. To eliminate my x, I'm going to add it down. That's going to eliminate the x, and I get -2y plus 350y is $1.50. Y is equal to -1,400 plus 2,048 is equal to 648. I'm going to divide by 1.5 to both sides, and I get y to be 432. Now, this problem is only asking specifically for, like I said, the large lattes. I have solved for y. That is the number of large lattes, so I am done. 432 is my answer. Okay, number 10, continuing on with systems of equations, is the point -20 a solution to the system below? Explain. Okay, we've talked about this. If a point is a solution, that means it works in both equations, not just in one, but in both. So I have to take each equation one at a time, and I have to plug in the point -20. Now -20, if that's my point, -2 is my x, and 0 is my y. Okay, so when I get to an x in my equations, I'm going to replace it with a -2, and when I get to y, I replace it with 0. Type the left-hand side of my calculator, you get -4, and that does equal -4, so that one checks. Okay, now we're going to take the second equation. Y minus 6x, does that equal -12? Again, replace the y with 0 and the x with -2. Does that equal -12? Again, type it in our calculator to be clear. 0 minus 6 times negative 2 is actually positive 12, which does not equal negative 12. So I would say that that is not a solution, okay? So it is a solution. Is it a solution? No. Okay, the point is not true in second equation. Okay, or the point doesn't work in the second equation. However you want to word it so that you're clear to say that it is not a solution because it didn't work in both equations. Okay, number 11, solve the following systems of equations algebraically. All right, so if I look at these, they are clearly set up for elimination. How do I know that? I have x's on top of x's, y's on top of y's, my equal signs line up, and my constants. I can also tell that I have coefficients for every x and y value, so it wouldn't be easy to solve for x or y. So these are the problems that are definitely set up to use elimination. Now as I look at my coefficients, I say, is there a number that I can clearly multiply by the one of the coefficients to get the value of the other? So in other words, is there a number that I can multiply by 4 to give me 8? Well, yes, 2. So if I multiply this bottom equation by 2, that would give me 8x. Remember, we want the same number but opposite, so I'm going to multiply by negative 2. Okay? Okay, so I went ahead and multiplied this through. The top equation stayed the same. The bottom equation, I got negative 8x plus 6y equals negative 10. Now, in order to eliminate that x variable, I'm going to add down. Okay, that's going to cross out the x's. And so I would get 1y, or just y, is equal to 11 plus negative 10 is 1. So I now have my y value of my solution. I need my x. So now I'm going to take that and I'm going to plug it back in for my y value in one of the equations. So I'm just going to take this top equation, 8x minus 5 times 1, replace the y with the 1, equals 11. So 8x minus 5 equals 11. I'd of course have to add 5 over. 8x equals 16, divide by 8. I end up with x equals 2. So now my point of intersection is 2, 1, and that would be my answer. Okay, number 12 is about graphing lines. It's just asking me to graph this line. Of course, I know if I want to graph this line, 3x minus 2y equals 8, I have to get it into y equals form. So I'm going to work down through until I get to y equals form. Okay, first thing I need to do is move my x terms to the other side. So I'm going to subtract 3x to both sides. So that'd be negative 2y equals 8 minus 3x. Okay, now I need to isolate my y, which means I need to get rid of that negative 2. The operation between the negative 2 and the y is multiplication. So to get rid of it, I would divide everything through by negative 2, leaving me with y is equal to 8 divided by negative 2 is negative 4, and then I have negative 3 divided by negative 2. If I type that in my calculator, I get positive 1.5. When I turn that back into a fraction, I get positive 3 over 2x. Okay, so that gives me now, of course, my equation in y equals form, which is what I wanted. Okay, so I don't need this anymore. All right, so now if I want to graph my line, I need to identify two things. I need to identify my y-intercept, and I need to identify my slope. My y-intercept is the number standing all by itself, which in this case is negative 4, and my slope is my number attached to the x, which in this case is positive 3/2. To graph this line, I go to negative 4 on the y-axis. So down 1, 2, 3, 4. I plot my point. My slope is rise 3, run forward, or to the right 2. So rise 3, run to the right 2. Oops. Okay. Once you get a few points on there, you can go ahead and connect those points by drawing in your line. I don't have a ruler, so I'm doing the best I can. You, of course, should always use a straight edge or a ruler or the edge of your calculator, or the edge of your planner, something so that you make nice, neat lines, especially on a quiz or a test. Okay, let's move on to the next one. Okay, our next topic is our systems of linear inequalities. So this is what we just did in class, and so we definitely want to pay attention as we review this to make sure we have it down pat for the test tomorrow. Okay, number 13, you can spend at most $21 on a fruit. Blueberries X cost $4 per pound, and strawberries Y cost $3 per pound. You need at least 3 pounds of fruit to make muffins. Write a system of linear inequalities that represents this situation. So again, there's that tip or that hint that we need to write inequalities to represent the situation. Okay, they're telling us that blueberries are X and strawberries are Y. So let's keep that in mind, okay? Now, I'm going to look for my key words that tell me inequality words. And so as I'm reading through, I see one key that says at most $21. At most $21. Okay, I know that at most means that's the most I can have, so my inequality would be less than or equal to 21. Okay, now since I'm bringing dollars in to the right-hand side, I need to bring dollars into the left-hand side. So blueberries are X, it's the number of blueberries that we have, or the number of pounds, I'm sorry, and strawberries are Y. And so we have to bring in, if I talk about pounds plus pounds, I'm going to get pounds. Well, if I need to get $1, I have to talk about how much each of those strawberries and blueberries cost per pound. And that's what this information right here is. $4 per pound for blueberries, so that would be my 4X, and $3 per pound for strawberries, so 3Y. Okay, there's one inequality written. Now I'm looking for my keyword for another inequality keyword, and I see at least 3 pounds. So at least means that's the least you can have, and so at this time it's greater than or equal to 3 pounds. Now, since the unit of measure on 3 is pounds, I should be adding two things that are talking about their pounds, which this time it's going to be blueberries, the pounds of blueberries plus the pounds of strawberries. Has to add up to at least 3 pounds. Okay, so now what I need to do is graph this system. So each one of these inequalities needs to be kind of handled on their own and graphed. So I'm going to take the first one, the 4X plus 3Y is less than or equal to 21. And in order to graph that, I have to get Y by itself. So I'm going to move my 4X to the left, to the right-hand side. Oops. So I would have 3Y is less than or equal to 21 minus 4X. Then I'm going to divide by 3. So I have Y is less than or equal to 7 minus 4/3 X. Okay, sometimes, like the ones we did in class, we actually have to type these into our calculator and get a, and scale the axes and do all that, and we have to really get some points on our graph. But in this case, you can see that these actually, they've counted on the X and Y axis by 1. We have a Y-intercept of 7 here, and a slope of negative 4/3. Both of those are very manageable without going to our calculator at all. So we're going to go up to 7 on the y-axis, and we have a slope of down 4, so 1, 2, 3, 4, over to the right 3. So I'm right there. And I really don't even have enough room to go for another point. Those are the only 2 points that I have room to plot. So I'm going to go ahead and connect those as neatly as I can here. And it would be with a solid line. And then I need to shade because it's an inequality, and so I'm going to shade below because it's less than or equal to. So I'm going to shade like this. It's helpful to use 2 different colors with these. We talked about that just so that you can really see where they intersect. Okay? And somehow it's also a good idea to make sure that we label this. Okay? So y is less than or equal to 7 minus 4/3 x. All right, now I need my other inequality. So I'm going to take the x plus y is greater than or equal to 3. This one's a little easier to solve for. All I have to do is move the x. So y is greater than or equal to 3 minus x. Once again, it has a very manageable y-intercept of 3 and a slope of negative 1 over 1. And so now this time I'm going to go to 3, and I have a slope of down one to the right one, down one to the right one. So as I connect those, again with a solid line because it's greater than or equal to, and this time I'm shading above. So all of this gets shaded. And so we end up, okay, with this intersection right in here. All right, and I'm going to go ahead and label my region up here. Y is greater than or equal to 3 minus x. Okay, that's the whole green region there. So now my intersection zone, or the solution zone, if you will, is this area right in here. So I'm going to go ahead and color that in. Okay. So anywhere between those two lines is really a point that would represent the intersection. Okay, and it's nicer if you can do this on yours and you can use like a highlighter or something so you can still see the grid. So it's kind of tough because now it's hard for me to see the points, but I can still get a pretty good general idea that that right there is my solution zone. Okay, in there, any point in there will satisfy the solution for this system of inequalities. So part C says use the graph to determine whether you can afford to buy 4 pounds of strawberries, so over to 4 pounds of strawberries and 1 pound of blueberry. So that would be this point right here, which we can clearly see is in our solution zone. It's right here. And so we would say yes, this point, which of course would be 4, 1, is in the shaded region. Okay, so that's how we complete that one. Let's go ahead and move on to the last couple. Okay, the last topic is properties of real numbers and rational versus irrational numbers. So number 14 says, circle the expression or expressions that would result in a rational number, indicating we could have more than one. Okay, so with these, when I'm verifying if it's a rational or irrational number, the best thing to do is type it into your calculator. So I'm going to encourage you to just kind of pause the video for a second if you haven't already and type it into the calculator and see what you get. I'm going to do the same, and I'm going to write down what I got as numeric answers. Okay, so and then when you come back, we can see if we agree. Okay, so these are the numeric values that I got when I typed them in. If you didn't match, I would just be careful that when you're entering in, for example, when I enter in root 4 plus the square root of 12, make sure that after you type in the square root of 4, that you use your right arrow to get out of the radical, then type in your plus sign, then type in the square root symbol again, and then the 12. Then hit enter. So you should get this decimal. If you get that decimal, the question is that rational or irrational? That is very much irrational, so I'm going to cross this off. It is not one of the rational choices. The second, Roman numeral 2, 1 over the square root of 16 plus 1 over the square root of 9. When I type that in my calculator, I got 7/12. 7/12 is a fraction, which is a rational number. Okay, 7 is an integer, 12 is an integer. When two integers are dividing and written as a fraction, that is definitely a rational number. Roman numeral 3, radical 10 times radical 5. In my calculator, I got this decimal that kept going on forever. That is not rational. Roman numeral 4 was radical 3 times radical 12. When I typed that in my calculator, I got an answer back of 6, which very much is a rational number. Remember, rational numbers are decimals that terminate. So decimals that terminate or repeat. Okay, terminate or repeat. Okay, number 15, last one. Write an example for each of the following properties. So we have 3 properties that we want to take a look at. The first is the distributive property. The distributive property is when you pass a number out by multiplication to 2 numbers in a parenthesis. So for example, 2 parentheses x plus 3. 2 is being multiplied to the binomial x plus 3, so we pass it out to both. So it'd be like 2x plus 2 times 3, or 2x plus 6. Okay? The next property that we have there is the associative. And the associative is all about grouping. So keep in mind, it's all about grouping. And so if I had, for example, x plus parentheses y plus 2. Okay, right now, what is grouped inside the parenthesis is the y plus 2. If I change the grouping, but not the order, that's the associative property. So that'd be x plus y in parentheses plus 2. So again, if you look at the order in which I read these terms from left to right, xy2, xy2. The order has not changed, just what's inside the parentheses. That's associative property. Last one is commutative. Okay, commutative property is all about order. That's the one where the order matters. Okay, so I'm going to use this actually the same example, x plus y plus 2. There's two different ways that I could show the commutative property. The one thing is to go ahead and change the order inside these parentheses. Okay, so if I change it, I would have still x plus, but inside the parenthesis I could have 2 plus y. So notice the order inside the parenthesis has changed. The other thing that I could do with this first example, or this example in order to show you commutative property, is actually switch the order of this term and the parentheses, right? If I flip-flopped these and put the parenthesis first, y plus 2, and then put the x at the end. That's another example of the commutative property. Order is changing, but what's inside the parentheses did not. Okay, what's actually inside the parentheses did not as far as the terms, just the order is changing. All right, guys, that was a lot. I really thank you for going through this review with me. I hope, like I said when I started this video, that you did these problems on your own first and that you use this as a reference just to kind of quickly check or just another tool to study and review before your test. Please, 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 if you still have more time and more opportunity, go back through your notes and retry problems that we've done in your notes. I've talked about just kind of covering them up and trying them again, especially those word problems and even some of the graphing. If you grab some graph paper or print it off the internet and just try to re-graph and re-practice through those. Okay, make sure you know how to use your calculator to help you answer these questions. Make sure you know what to put in there, all that kind of stuff. If you need help and there's still time, come and see Mrs. Hennessy or myself and get the help that you need before the test. Study, study, study. You definitely can be successful in this test. Let's give it your best effort so we can get your best grade out. Okay, thanks so much, and I will see you in class.